afternoon, and some of you have to take trains, planes, and so on. This is automatic detection of inadequate authorization checks in web applications. I know it's a kind of academic title, but this is Cambridge, so what the hell. My name is Alvaro Muoz. I work as a software security researcher for HP, Fortify. I've been doing security-related stuff for the last 10 years as a pen tester and application security consultant. If you're wondering where my accent is from, I'm from Madrid, Spain, so please don't mention the World Cup at all. And if you want to contact me, well, this is my HP email and my Twitter handle. I would like to virtually introduce you Divya. Divya was the original researcher for this project, but she couldn't make it here to Cambridge, although she's actually working based on London, UK. She worked on his postdoctoral research in working similar techniques that the ones that we are going to present today, but for operating systems, services, daemons. So this is just like an evolution for web applications. Okay, so the idea for this talk is to talk about, first of all, what's the distinction between design flaws and code level bugs. Why should we care about finding design flaws? Are they important? Are they popular? Are they present in the real world applications? What are the current detection techniques? So how can we find them today? And we're going to propose like a solution, a new technique, a novel technique to find them using purely static analysis approaches, right? So it's something that has been done before, and well, this is just not even a beta, it's a POC, it's working, and we are proving it in real-world application with very good results. So it's something that we eventually will end up in the product. So first of all, the distinction between code-level bugs and design flaw, is it clear for all of you? Well, just to make sure that we are all in the same page. Code-level bugs are bugs that we can I change the mic? I think maybe the water. Can you hear me if I speak like this? Okay, fine. Okay, thank you. So just to make sure that we are all in the same page, code level bugs are bugs that we can find in 3, 4, 20 lines of code. So we have a source that is clear state in the source code, and a sink, and we have a data flow or a structural pattern that we can find purely in the code. Design flaws, we require to check the specification, the design of the application to make sure that it's a design flaw or is something that is supposed to behave like that, right? So let me put some examples. For example, code bugs is a SQL injection, cross-site scripting. You have a source sink, and you can see how the data propagates from the source to the sink, and you don't have to check the requirements or the specification for this particular application to make sense out of the SQL injection and find that this is a bug, right? However, with design flaws, imagine, for example, an application where you have an application to manage your employees' expenses. So if an employee can approve his, or actually if a manager should be able to approve his employees' expenses, but not his own expenses, right? It's something that is common sense. However, if the application is not checking for this control, then it's going to be a design flaw. If that is specified in the design, like for example, managers are not supposed to approve their own expenses and things like that. So this is a design flaw because even if you are actually in the code, you can see that there is a missing authorization check. You have to go to the specification and make sure that there is a requirement saying that you should be placing an authorization check there. So this is somehow the mandatory funny picture, but it has a goal. Do you think that this is a picture level bug or a design flaw? How many of you think this is a bug? Really? How many of you think that this is a flaw, a design flaw? And how many of you think that you don't have enough evidences with these pictures to actually know if this is a design flaw or a code level bug? Okay, I'm more with you, but we are open to other suggestions. So maybe this street is just right in front of the Tate Modern Museum, and this way of planting the trees is something that is this way by design, right? So we cannot tell that this is a design flow without checking the specification. So that was kind of the purpose of this slide. So let's take it to the code that we are more familiar with. This is a typical web application where we have different roles. So for example, we have an administrator role that have access to an admin panel where he can create or delete accounts. Also, we have a user view where the user, as a regular user, cannot access these features because are supposed to be only accessed by administrators or some special privileged accounts. Now, if this is the code in the backend server controller, so looking at the code, can you spot any problem in this Spring code? I don't know if you can actually. So there are two functions here, the create account and the delete account. And one of them is mediated with this pre-authorized annotation, right? So it's checking that once that you are going to call this function here, the create account, it's going to check that you have the right permission, the right role in order to execute and run this function. However, the delete account is actually missing this check. So anyone from the previous user interface can actually delete any of the accounts without being an administrator and just finding out which is the right URL and just executing and accessing this method. Okay, so for code level bugs, it's something that is supposed to be easy to find with static analyzers, right? Because static analysis are supposed to take the code and have complete visibility in the source code. So if the code is completely contained within the source code, should be easy to find there, right? So maybe you have to fine-tune this static analyzer for the particular technology stack that you're using. So you have to have a good coverage for the libraries, frameworks, language that you are using. But once that you get to that level, you are supposed to find, if not all, most of the code level bugs using a static analysis tool. However, for design flow, it's not that easy because you have to check the documentation. You have to check the architecture, the requirements, the specifications, and then you have to check the code, check that the delete account method is missing an annotation, and then go back to the specification of the application and try to find out if it was supposed to have an authorization check there or not. So in order for a static analysis tools to be able to find design flaws, they should be able to take this pile of documents there, put them into some format that the tool can understand, and then run the static analysis tool to find missing authorization checks. But this is not practical because there is no way, actually there is no standard format to do that. And even if we all find a standard format to do that between different vendors, open source tools, and so on, we are going to translate like plain English requirements, like for example, this manager should be able to only approve his employees' expenses, but not their own expenses. We have to translate that into this set of functions, like the approve, expense, or whatever you call it, are supposed to be executed only with role manager. So that's not an easy translation and requires a lot of, of involvement. And if we want to make it like scalable, then, I mean, if you're going to scan one application, there is no problem, you can do that. But if you're going to scan like hundreds or thousands of applications in your organization, then this is not a practical approach. OpenSUM have a very good distinction between code level bugs, design flaws, and they have these verification activities right here, design review, code review, and security testing. Actually, design review is supposed to find design flaws, right? Just by reviewing the design, the specification, the architecture, finding flaws there. Code review is supposed to find code level bugs. And security testing is like a second layer of protection to make sure that you did a good design review and a good code review. So if you did a good review of these two previous steps, you should not be should not be finding many issues during the security testing activities. Now, if you go to the code review activity in OpenSUM, you will see that the second level of maturity here says that you have to do some code review, right? Because again, if you have one application, then you can do it manually. If you have hundreds or thousands, you want to automate that in order to do it more scalable. Also, if you want to be even more mature in the OpenSAM scale, then you have to fine-tune the application, the analyzers, in order to understand the technology stack that you're using. However, if you go to design review, there's nothing like that. There is some services here, some gates there in order to create meetings to review the documents, the specifications, and the architecture of the application, but there is no way to do it in an automatic fashion, right? And this is a problem because we are seeing that there are many design flows that could be identified with static analysis, and we cannot do that because there is not technology support right now for that. So this is OWASP Top 10. If we focus on the last year version, there are 2 of them that are design flows. And with design flow, there are many categories, right? We have like missing authorization checks. We have, for example, broken logic in the application. Like, for example, if you change the order when you're buying something, then you may be able to buy something for free without paying for that, and so on. But if you focus on the top 10, it seems like the most prevalent or more popular ones are the ones related with missing authorization checks. So A4 is insecure direct object reference, and is basically if you are exposing an object or a resource in the server, and you're actually not protecting it with an authorization check, so the URL to access this resource can be predicted. And for example, you have some confidential data or resources that can be accessed just by predicting the URL. So one example for this is the Bloomberg when they grab the NetApp earnings just by accessing a different URL with a different date and so on. The other one is A7, right? This is new this year, actually last year, and it's a missing function level access control. So now we are not talking about resources in a web server. We are talking about the exact example that I showed you with the admin panel, creating an account, deleting an account, when you have some controls to show some controls or not, depending on the role that you have, but you are not replicating these controls in the backend. So you are missing the authorization checks at the function level, and then you're opening the doors for attackers to predict the URL and access those resources. So one example is the Citibank hacking like some years ago in 2011, when they were able to change the user ID in the URL, and just by changing the user ID to another ID, they were able to access sensitive data from these users. Because actually they were missing like a function level access control there. Okay, so what are the current approaches to find this kind of missing authorization checks? As far as I know, the only approach right now is dynamic, and it's basically scanning a web application with 2 or more different roles, comparing the results. So you have like an attack surface for administrator, an attack surface that is different for a regular user, then you compare them, and the extra attack surface that is available for the administrator, you can scan it using a regular user, for example. Then if you find new pages, or these pages that are supposed to be accessible only for administrators are accessible for regular users, then you can raise a flag and say, this is wrong or should be different, right? But one of the limitations is that it's dynamic, so you have to set up everything. You have to ask permission to set up the application in the pre-production environment, QA. You have to ask permission to scan it. You have to prepare everything, so it takes more time and it scales worse than static analysis. And also, it can only detect missing authorization checks. So it can detect that you can access something, but it cannot detect that there may be different ways to access the same resource with different authorization checks levels, right? So what we are trying to find is a solution that works for web applications that is static, purely static, so we can scale it and run it on thousands of applications very quickly, and also that finds both missing authorization checks, but also inconsistent checks. So things like this function can be accessed through this path here, with asking, for example, for an administrator role, and through this other path can be accessed without being an administrator. Just by being authenticated into the application, you can execute the exact same code. And the most important thing here is this requirement is not require any training or any preparation for the tool. Because if you have to take the documents, the pile of documents that I showed you before, translate them from English into a XML or any format, and then feed the static analyzer with that, there's no, I mean, it's not going to work. It's going to work with that, one application maybe, but it's not going to work, and it's not going to scale. So this is our approach. This is a three-step approach. The first thing that we are going to do is create a specification of the application. So what is currently being access checked? So what functions are being protected? Then we are going to identify all the operations within those functions that are being protected. And in the second step, we are going to find those functions that are not protected. We are going to find the operations that are contained within those functions that are not protected. And then we are going to cross-check them, find the anomalies, and present the developers with some suggestions, some remediation advices on how, where is the missing authorization check and what authorization, one check should be placed to protect that part of the code. So the first part is creating the specification. And to create the specification, you have to identify all the methods that are protected with access checks. And for example, we started only with Java, and actually we are only working with Spring Security and Apache Zero right now. And these are the ways that we found that these frameworks, Apache Zero and Spring Security, are protecting the code, right? So they can do it just by using URL access checks, aspect-oriented programming with point cats, annotations throughout the code, or programmatic checks like if-else checks, like I'm protecting this block of the if-else statement and not protecting the other one. We also have to consider not just these functions that are being protected with, for example, an annotation, but if this function calls a different function, the second function inherits the same levels of protection that the first one. So we have to keep track of the way of calling these functions and protecting all the possible paths. So some examples of how the applications are actually being protected right now with Spring Security. This is a configuration file for Spring Security. This is the intercept URL tag. And basically what you're seeing here is anything in this map to the admin URL is going to require the hash role administrator, right? This is a different URL pattern index, and it's going to require the user to be authenticated with any role, user, administrator. This is just one example. Aspect-oriented programming, point-cat based, so you can say things like, when the code is going to call any function within the com service namespace, it's going to check that the user is role user, right, for example. So it's going to intercept the calls to these functions, and it's going to place some access checks for those functions. Another way to do the similar thing is by protecting or placing these same checks at the method interceptor or at the bin level. So at the bin level is the most obvious one. So you have this bin, for example, the demo account service implementation, and you want to protect the create account and require be user, and to delete an account, you require the user to be an administrator. The other way of protecting is just placing all of the access check together in the same list. So it's a centralized point of placing all the checks. As you can see, there are many ways of protecting the functions, placing the functions using aspect-oriented programming, URLs, annotation. So we have to account for all of them and identify those functions that are being protected. So this is another way of protecting using annotations. The first example is Apache Zero. So in the first example, there are two annotations protecting and asking or requiring two different sets of permissions or checks to access the post and find accounts methods. The second example is Spring Security, and it's basically the same idea. You have some methods that are being protected by annotation. So any operation that is contained within that function is going to be protected, and is going to require the user to have those access checks. A different place or layer where we can place authorization checks is in the view layer. So we can do things like, I'm going to show these controls if the users are authenticated, or I'm going to show this greeting, for example, if the user is an administrator, or I'm going to show this delete and create account controls, like I saw before in the example, if the user is an administrator. So we are not caring about this access check at this point. They are important because if we find that there is an access check in the view and in the corresponding part of the controller is not being checked, then we can find that there is something wrong. Because if you're not showing something, normally it's because it shouldn't be accessed by that role, right? But we are now focusing right now in the backend, in the controllers, in the services, and so on. Okay, so the last way of placing access checks is at the block level. Instead of protecting a whole function, we are protecting just a block in an if-else statement. Look, for example, this one is protected by the hash role administrator. This one is not protected, right? So all the operations within the protect block have to be considered for the analysis and to be placed in the specification. So the first step within the first step, that is creating the specification, is to identify all the functions and all the blocks that are being protected. The second step in the first step, that is the create a specification, is to identify all the operations within those functions. And for an operation, we refer to a verb and a direct object, right? So for us, an operation right now is just a function call. We can also consider in the future variable assignments or other type of operations, but we are now only caring about function calls. And when you call a function, you are invoking a function that is the verb, what is going to be done, and the variable, it can be, for example, the instance object or one or several of the arguments, is the direct object. It's the object that you're going to action upon. Also, we have to discard some of generic methods that are going to be all over the application, like login methods, methods that are being called from many different call sites. So they are going to be heuristically detected and basically discarded because we cannot infer missing authorization check by a method that is being called from anywhere, right? Okay, so this is one example, a simple example where we have two different methods. The first one is getCocktail, and it's protected by the pre-authorized check, and is actually accessing the get method in the cocktails variable that is actually a list, right? A Java list. Now, we have another method here that is the delete cocktail. It's accessing the same exact operation, so it's the same variable being accessed. It's actually the class member, and it's accessing the same method on the same variable. However, this one is not protected. So we can infer from here that maybe the developer forgot to place an authorization check in the delete cocktail because of the set of operations that are being protected in a different operation. Now, a more complex or more realistic example, we have, for example, the same idea of a getCocktail method here in the middle. However, the authorization check is not placed right in the implementation method, but in the interface. So this interface declaration, and actually here in the method implementation, it's inheriting the authorization check from here. But also, if you see, there is a mapping here to the admin URL. So this method is invoked and is mapped to the admin getDrink URL. So there is another authorization check that is mapped with the admin URL pattern, right? So we have to consider all these authorization checks. In this case, it's requiring is authenticated. So this method is going to be protected by both the pre-authorized annotation and the is authenticated check. And all the operations within this method, in this case, there is only one, the lookup cocktail, are going to be protect and inherit all the set of checks, right? So in this case, you can see here that the implementation of the lookup cocktail contains a call to cocktails.get. So in this case, there is one operation that is cocktails.get, where the verb is get and the direct object is the this cocktail variable, and it's being protected by two different sets of annotations, of checks. Does it make sense? Yes? A little bit? Okay. So second step, we have now a specification, right? We have a list of all the methods that are being protected and a list of all the operations that are contained within those methods that are protected. So now we are going to find anomalies. So given a specific class where we have found methods that are protected, we are going to look for other methods that are not protect, and we are going to look for the operations within that method. So we are only going to focus on the same class or methods invoked with a call stack that access that class, because normally developers place the access checks at some layers. So for example, the service layer or the data access layer. So we don't want to just check for all the classes and look for missing authorization checks in helper classes, utility classes, and so on. So we are going to look for the same set of operations, right? So for example, in the non-protected methods, we are going to look for operations that are going to be identified or profiled by a function and one or more variables that in this case can be the instance object, arguments, and so on. Also, we can fine-tune the operations. So for example, imagine that we are accessing some methods in an ORM framework. So we have the typical CRUD actions like read, update, delete, create. So normally, they don't require the same level of access, right? So the read is normally less privileged than the create, delete, or update ones. So if we can map some of the operations to CRUD actions, we can actually provide more accurate results to the developers. So we are classifying all the operations or all the anomalies that we find. So we cross-check those operations that we found in the non-protected method with the operation that we found in the protected ones, and we cross-check them and create a list of anomalies. So if they are acting on the same variable and the same method, we call them this internal name, like same var, same method. It's just like a label to identify this class of operation. So each of these 4 levels are going to have a different severity, because if we find that something is an operation on the same variable and on the same method, this is going to be critical because it's going to probably is missing the authorization check. However, if it's the same type of the variable, same type and different method, maybe it's, and we will show you some of real-world examples with verified missing authorization check where the actual pattern of the operation is same type, different method. So they can be true positives, but the probabilities for them to be true positives are lower than a same var, same method, right? So this is the example that we saw before. In this case, get cocktail is the same variable, is this cocktail that belongs to the class, it's a class member, and then the get function. So as the delete cocktail and the get cocktail are invoking the same operation, we can infer that there is a missing authorization check. Now, we are not only looking for missing authorization checks, but also inconsistencies, right? So if, for example, we find that this method can be invoked from the get cocktail and the delete cocktail, and one of them, one path, require the user to be administrator, and the other one just require the user to be authenticated, we can present the developer with, this one is missing the administrator check, or this one may be missing the is authenticated check because it's inconsistent by itself, right? Okay, so suggest remediation. This is the most important part because we have to present the results in a way that is easy for the developers to understand and that provide them with enough evidences to support our findings. So basically what we are doing is presenting what are the functions or the operations that we identified as anomalies, and we are providing evidences from other places in the source code where we found that those operations were protected by some authorization checks. Sometimes we have to provide the developers with a call stack. So for example, we found that this operation is similar to this one that is protected, but this one that is protected is not directly protected. It's invoked, and this is a call stack of 4, 5, 6 method calls, and in the top of the call stack, there is an annotation protecting the enclosing method. So we have to provide them with all the evidences and all the information they need to quickly identify if this is a true positive or not. Okay, so this is a summary of the steps, the 3 steps for the example that we have been using. So the first step is create a specification, profiling the application, identifying all the functions that are being protected by access check, identifying all the operations within those functions. Then in the second step, we are going to identify all the functions that are not being protected, identify all the operations within those functions, cross-check them, and provide the users with a list of findings, right? Okay, so now some real-world examples in the wild. So MIFOS or MIFOS, well, we run this POC in a bunch of open source project in GitHub. This is the one that, the biggest one. I will show you also the smallest one. This one is 300,000 lines of Java code and 100,000 lines of XML. And it's a pretty big application, and it uses both Spring Security annotations, but also some custom checks. We identified 77 anomalies in the application, and some of them are false positives because we are not checking for custom checks right now. And for custom check, I mean they created this has role method or has privilege or has permission, and they have their own library that is not Spring Security, it's not Apache Zero. So we still have to provide the tool with a way to, take this information. So these are the packages that we use in our technology stack, in our library to protect or to check for authorization checks, and just feed the tool so they are considered in the same way that, for example, we are doing with Apache Zero, has role methods, and so on. So these are some of the examples. For example, this one is a same bar, same method, so the most critical level, right? So there is this method here called transfer client to branch that is enclosed by, or belongs to the class client service facade web tire. And as you can see here, the suspicious operation is the transfer client to, that it acts or operates in this customer service. So we found that there is a different method called transfer client to group. So instead of to branch, to group, that calls the exact same operation on the exact same variable with the exact same function. And the other one is actually protected by requiring these two methods right here. So all these examples that I'm showing now have been disclosed to the open source projects. They have been verified, and actually they have acknowledged that these were actually missing authorization checks. So if you go to the code, I know that the font is a little bit small, but there is this transfer client to here in the transfer client to group. The same operation is right here, this customer service transfer client to in the transfer client to branch. And actually there is no access check here, but if you go to the interface, because this method at overriding the interface, then you can see that the transfer client to branch is not protected, but the transfer client to group is protected, is mediated. So we can infer that we can present this finding to the developers. And as I said before, it's 77 anomalies out of 500,000 lines of code. So it's not like, yep. Yeah, because we first create a set in the specification. This method here, for example, client transfer to branch, will be identified to be protected with two different annotations. And one annotation and one access check, and then it will know that it's protected by two, well, actually it will find an inconsistency, right? So it will know that this one is protected by the annotation, and this one is protected by the URL. And it will present like this is not consistent, like the example that I showed you before. So another example is in this create question group. It belongs to the question service facade implementation, and it calls or it contains this operation here, the define question group. And it's acting upon this questionary service, right? So we found an evidence that actually is called create active question group instead of create question group that contain the same variable, same method operation. So we can infer that since one of them is mediated, the other one should be mediated. Actually, if you go to the source code, you can see that this is a copy-paste of the same method. So there is no reason if one is protected to not protect the other one. So we tell that to the developers, and they agree that they forgot this is the interface. As you can see here, one of them is mediated, create active question group, and the other one is not. So they acknowledge that this is a missing authorization check. Third case, it's same type, same method. So now we are not acting on the same variable, but on a variable of the same type. So in this case, it's a constructor, I think. So there is a method called getServerInformation that is calling the constructor of the system_info class. There is an evidence saying that there is another method called system_information, getSystem_information instead of getServerInformation, and it's also calling the constructor of system_info. If you go to the methods, you can see that both of them call the constructor here and here, but if you go to the interface, one of them is mediated and the other one is not. And actually, I don't know if you realized, but normally the ones that are not mediated are the last one in the interface. So like, it seems like the developers just wrote the implementation, copy the signature of the function into the interface, just copy paste, and they didn't understand the annotation, so they just leave it like that. This is just my idea. So this is another application called PJ Gallery. It's a very small application, just like almost 2,000 lines of Java code, and we found 8 anomalies. One of them that we reported to the developers and was acknowledged was this one. So actually, this is same variable, different method. So it's actually calling on the same exact instance of the variable, but completely different method. In this case, the get breadcrumb by ID is calling this operation here, get breadcrumb by ID on this album mapper. And we found not one, but 2 evidences of operations on this album mapper that are being protected by this set of operations, of annotations here. So even if get root and get by parent has nothing to do with get breadcrumb by ID, we report it as lower severity finding, saying that it may be that you're missing something here. And actually, they acknowledge that this is a true positive. So they were actually missing the annotation. So you can see the methods here, get by parent is protect. All the methods in this class are protect except by the last one. Again, the last one. So this is just my suspicious. So that's pretty much it. Next step, we want to work on just working on custom authorization checks, because many frameworks implement their own stack or their own libraries for authorization checks. Another area where we can improve is reducing the false positives, so things like mapping the operations to CRUD actions, like I explained before, or increasing the granularity of the operations. Also extending to other frameworks, other languages like .NET, or other frameworks like, I don't know. By the way, I don't know if you know more Java authorization frameworks apart from Spring Security, Apache Zero. Okay. So this is pretty much it for me. If you have any questions. Please. We are only supporting Spring Security, Apache Zero, and we are going to start supporting custom authorization checks. So maybe with custom authorization check, we open the set of programming styles, as you said.
My problem with this is that usually you want to audit like bad programs, like badly written programs usually means like bad security. And those are the ones you want to audit. But with this one, you cannot audit like badly written programs.
You have to consider that this is something that hasn't been done before, using static analysis to find this type of design flaws, because finding design flaws and trying to figure out what the developer was trying to do is very difficult, right? So, and this is just like the first steps into that direction. And I think this is the right way. I mean, we know that it's limited to this set of annotations in Spring Security, Apache Zero, these ways of defining access check, but I cannot imagine more ways to define access check. So aspect-oriented programming, configuration files, if-else statements, annotations, what else? So it's going to be among these lines. So,
Have you worked as a developer before?
sorry?
Have you
not work, but I have developed many applications.
There are tons of really like code that does not look like that at all.
So
Not
I would
code.
I would love to not really to get more ideas on what kind of operations we should be checking for, what kind of access checks we should be getting checking for based on real world experience. So I would really appreciate if you can share that. Right now, it's not an open source project, so it's just a POC. So we will see. I will. I don't know. To be honest, this is right now an HP project, so at some point it will be released, but I cannot talk about that. Sorry. Yeah. Mm-hmm. Mm-hmm. So we haven't considered like machine learning for this approach, but I don't see any reason why not extending and adding capabilities of machine learning to cluster some operations and improve the accuracy. So as I said, this is a first steps, proof of concept, and we are trying to improve it and make it really useful for developers. Anyone else? No? So thank you all for coming and staying this late, and thank you.